All right, guys, here's the next problem that we have. It's the function, and it gives us as an exponential, represents the population since 2000. What was the population in the year 2000? Well, that would be the y-intercept. So the first answer is 2048. We know that because the y-intercept is before the growth factor in an exponential. At what rate is the population increasing? All right, so if it's a growth, that means that it was 1 plus the rate. So here, if it's 1 plus the rate, that means the rate must have been 0.25 or 25%. In what year will the population be 6,250? I'm not going to go and do this one, but remember, they're giving you the y. So you're going to graph the equation, and you could simply look at your table to find out when y is 6,250. Next one, look at the graph below. Oh, wait, I think I missed one. Nope. Look at the graph below. What is the x value where the graph is not continuous? Well, the graph is not continuous right here. You see there's a jump. So that would be when x is 2. Which the table represents the absolute function of just the absolute value of x. So when you put in a number, you should always get a positive answer. That's this one. When you put in a -2, you get out a +2. When you put in a 2, you get out a 2. What is the range of this function? Well, this one, because it's a real-life problem, it only goes to 0, and it goes up to 40. So you'd say that y is between and including 0 and 40. So that'd be this one. Scatter plot below shows the temperature of a cup of coffee as a function of time, curve of best fit. So here the exponential is actually a best fit. According to the curve of best fit, when will the temperature of coffee be 30 degrees? So I'm going to look for 30, and I'm going to go to the line, and it looks to be about 8.5. Maybe I'm a little wrong. I can't see it that well on mine. I guess it's 9 minutes. And again, I'm sorry if that's incorrect. I can hardly see it on mine. Number 5, what is the maximum value of the function? That would be this right here. So it would be the height of it, which would be 4. Okay, the number of hours it takes to do the job varies inversely with the number of workers. So that's xy equals k. It takes 6 workers 8 hours. So if I could find out k by multiplying them. So k is 48. So the equation would be xy equals 48. And that'll help me solve the next one. If there's 5 workers, I would divide 48 by 5 and get about 9.6 hours, or exactly 9.6 hours. What is the value of y when x is 6? So I go over to x of 6, and I go up. Remember, open circle does not include it, so I go up to the closed circle, and I get 40. Look at the table below. Does the table represent a linear, quadratic, or exponential? So remember, linear is when you're going plus or minus the same amount. Quadratic is when the difference of the differences. Or an exponential is when you have multiplying or dividing by the same amount. So here I have, it's not multiplying. It looks like it's +5. But here is +7. And here is +9. But if you look at the difference of the differences, it's constant. So that would mean it is a quadratic. The average speed and amount it takes to get home from vacation varies inversely. So remember, that means xy equals k. So to find k, I'm just going to take any old value of xy and do 20 times 12. And you get 240. So the equation is xy equals 240. The constant of variation is 240. And you could talk about how you multiplied. Now, if the speed is 50, so you're going to say 50 times y equals 240. Divide by 50, and it's going to take you about 4.8 hours to get home. And that's it, guys. Good luck studying. Remember that this test is on everything that we've learned in the Unit 7 packet, but chapters in the book are 10.1 to 10.6, and make sure you bring a pencil tomorrow.